into 2 to some power. And that's really the challenge here. That's the game. So to do this, you first start with 32. You say, okay, 32 is really 2 to the power of 5. Okay. And then there's it's just like, okay, it's supposed to go back and be like, all right, well, how do you move a number to an exponent out of the bottom of the fraction? Well, it becomes a negative exponent. These are all properties that we're using, rules, if you will.
Okay.
Okay. So the idea is that instead of 1 over 32, you can write 2 to the minus 5. Like if you were to go to a calculator right now and type in 2 to the minus 5, you would, and type it as a fraction, it would be 1 over 32. So the reason that's so important is that this becomes log base 2 of 2 to the minus 5 power. And just like all the examples on the right here that I showed you, when the base is the same as the thing you're taking the log of, it becomes just the exponent.
Okay.
So this is the answer, but all the stuff that I wrote here leads to the answer. There's kind of a lot of, build up to that.
Got it. All right. I'm ready for number 6, I think. Yeah.
We're actually we'll go to 8 first, and then we'll come back to 7, 6 and 7. 8's a little bit more like 5.
Okay.
So the other thing here, and there's so many, like every one of these, really you need like 5 or 6 practice problems for each type, but you're only getting one. So, I'm gonna give you as much explanation as I think you need. Whenever the base is not written, the base is 10. So this really is log base 10 of 1,000. And it's really no different than like when you see an x is really x to the 1, and there's really a 1 in front of it, and it's really divided by 1, but we don't write all that. Like sometimes you just don't write the stuff that you're supposed to assume to know. But assumptions are bad, right? So you don't want to assume things. Okay, so now 1,000 can be written as 10 to some power. Any idea what that power would be? And if you're not sure, start with 1, then go to 2, then go to 3. You can figure out what 10 to what 1,000 is. It's 10 to some power. It's based on the number of zeros.
It's 3.
It is 3. So in this case, it becomes, this is a 3, log base 10 of 10 to the 3rd power.
Okay.
All right, so what does that become?
Hmm. Um. The answer
Base
would
is this,
be 3.
go ahead. Yeah,
Yeah.
perfect. Okay. All right, so now we can go back to
6 and 7.
the previous problems, yeah, and get those going here. All right, so the formatting is really bad here because the 6 is not part of the problem, but it could, like, there's going to be problems where there is a number in front of the log, so that's why I keep getting rid of it. We already know the answer to this, but it's one of those reminders. It's like, what's really the exponent there? The exponent is really 1. This equals 1. And there is no work. There's no like steps. Unfortunately, these are just properties. Although it does say, look at examples 5 and 6. So I guess I might as well go back and look at those. There really is no work for this one, but I want to make sure you don't get this kickback. Yeah, this one doesn't have any work. All right, let's type. Okay, so the next thing is log, sorry, let me go grab the question. I'm actually just write this one for number 7. So it's log base 12 of 1. So the property here is log base b of 1. No matter what base you choose, you can put any number or letter here. Any number or letter here, okay? This becomes 0. So it could be log 13 of 1. It could be log, 1,987 of 1, still 0. This is always 0.
Mhm. Got it.
All right,
So
on to number 9.
instead of a log, this time it's an E.
Yeah, so E and log, all sort of work together. Like they're inverses of each other. We'll get to that. But the this one says to evaluate this. Now we actually did this when we were graphing. It means to put 2 in for X. So this is E to the 4 times 2 minus 2 power, which is E to the 8 minus 2 power, which is E to the 6. Okay. Now you have to go to the calculator for this. And another reason we know is it says round your answer to 3 significant digits. Okay. So usually you don't see that except in like chemistry, some physics, things like that. That doesn't mean 3 decimal places. It means literally 3 digits, the first 3 digits that you see in the result. So if you got your Desmos calculator open up, go ahead and
So it would be like 403 basically.
right. And so you look at that, it is 403.4, and you decide, does that 4 cause the 3 to round up or down? Like you said, it becomes 403.
Mhm.
It's like when you're talking to someone, like if it's 403.4 miles away, you say, well, it's about 400. You don't need to
Yeah.
necessarily say like, oh, it's 0.4, and we're going to get there at exactly this time.
You don't use decimals when you're talking about like when you're talking to people like that. I guess. I don't know.
Yeah.
Yeah.
All right. Let's keep going here. We're going real fast through this lesson. That's great. I know the goal is to get through as much of this as possible. So let's keep it going here. Apply your knowledge. Apply your knowledge. Okay. Let me grab a snip of this. All right. Okay, go if you haven't read this, go ahead and read through this. I got to go look back in your lesson and see if they give you any equations for this, because I don't think that they do. And then otherwise I'm gonna have to. So the idea here is that if you had a chance to read through this, but it's really a base 10 scale of each number. And what they mean by that is the one in or the stronger one, we'll call it the stronger one. I didn't know if they were differentiating. It's really 10 to the 3.7. And then the weaker one is 10 to the 2.7. Okay, and they're asking to determine the ratio of these, the stronger to the weaker. Basically, they want to know how much stronger is it. And the issue here is that the earthquakes use what's called a logarithmic scale. So you can't just say, oh, it's 1 time stronger, 3.7 minus 2.7. They use the scale where you have to first convert it using base 10, and then you can compare the two.
Mhm.
So there's an exponent property here which allows you to subtract the exponents. This becomes 10 to the 1. And that's the answer. It's 10 times as strong. every once in a while when there's an earthquake, there's one pretty bad one in, I think, Turkey around Christmas time, New Year's, and they always write articles about the strength of the earthquakes, and it's in logarithmic scale, so it's a little bit odd for us because it's not just like, oh yeah, it's 1 time stronger. No, it's based on the relationship of these exponents.
Hmm. That's interesting.
Yeah. All right, so that takes care of that lesson there. Let's go take a look at what else you got for the week here. I'm going to go ahead and get reestablished with the website here. We'll move on to the next lesson. All right, so we got laws of logarithms next. Laws of logarithms. Does that sound right to you?
Yeah.
Okay. All right, so this one's going to take a little bit longer. It does because it says to state the laws that are being used each step. So there's going to be basically like a vertical line here. There's going to be the work and then the reason on the right, which is like a law. Did you have a geometry class where you did some proofs?
Yeah, I did. I took geometry this year as well. So
Cool. So you're familiar with this, and actually it just says the law. Okay, there we go. This isn't too bad, actually. I take that back. They're
yeah.
giving you, what?
Yeah.
I was gonna say, I found the laws. They just want you to say things like law 1 or law 2 or law 3. So actually it's not that bad. Law 1 is this product over here on the right. It says that the product becomes a sum. And then the next one here is that the quotient becomes a difference. And then this last one's the one we've been using a lot of. This is this third one here. It's where the a or the exponent comes out in front. And then they similarly have them for exponent rules. You probably have seen those in a previous course or earlier this year.
Hmm. I might have maybe.
Okay. So let's take a look at the first problem here. So you just have to state the law. You don't have to like rewrite it or anything. So it's good to just take a few minutes and look through the lesson and see what they've got here. So here we go. Problem number 1. It says expand log base 4 of 3x and state the law that is indicated. So the 3x is this m times n. Okay. And the idea is that, and I'll write it for the first one here. M is really 3, and big M is really, I'm sorry, let me just snip it in here and make it easier. So in your problem, M is really 3 and n is really x. Okay, so the log base 4 of 3x becomes log base 4 of 3 plus log base 4 of x. All right, so notice that the base b stays the same throughout. And notice that the product multiplication becomes a sum. And this is law 1. And that's the way your instructor is looking for you to present your answers here.
Wait. Just give me 1 second.
Sure. Yeah, I know I say a lot and then expect you to be caught up all.
Yeah. Okay. Does that say log with the 1 because I can't tell? Like,
Law 1
thank you.
on the right here. Yeah. Law 1, law 2, law 3.
Okay, I'm caught up by the way.
Okay. So the next problem here is probably going to be much of the same. We want to use the laws that they're giving. There's only 3. I mean, it's not like there's bunch. There's just, you got to know for this this instructor which one you're using. So I'm just going to rewrite what's here. Log base 3, 27 over x. And you should notice that that's a quotient. A quotient becomes a difference. And that's that's the words you would hear if you're in the classroom. It would say quotient becomes a difference. Here it is. So in your problem, again, you kind of have to decide, well, what is M? What is N? M is 27. N is X. So you're using this property here to rewrite the logarithm, log base 3 of 27. Actually, hang on, I need to rewrite it the way they're writing it. Sorry, I don't want you to get dinged for silliness here. Log base 3, 27 over X equals log base 327 minus log base 3 of X, like that. Okay, there's a bit more to do here, but let me know when you've got this down.
Okay. I almost got it down. Just I'm almost done. Hold on. Okay, I got it all written down. I'm caught up.
Excellent. Okay, I'm just looking here to see if they use what they use for this next part. If they do anything, it does not look like it. So what you're supposed to recognize here, and when I say supposed to, like it means like if you were the expert, you would see this. As a new student, you don't see this right away. 27 can really be written as 3 to the power of, like 27 is really 3 to the power of, and could you tell me that? 3 to what power? You need to try 1, try 2, try 3, try 4 till you get it.
I was about to say, actually, never mind. I forgot what I was gonna say.
You're welcome to grab that calculator and use it as needed for this.
All right. What do I write in the calculator is my question because I completely
Well,
forgot.
so rather than me just giving you the answer, I'm asking you to calculate what's 3 to the 1, what's 3 to the 2, and keep going
Oh,
until you get 27.
I feel like I might know it. I'm just gonna. Yeah, it's 3 to the power. It's 3 cubed.
3 to the power of 3, good. So you can now rewrite this as log base 3 of 3 to the power of 3 minus log base 3 of x. Okay, there's no law. This is just a rewrite step. Okay. And
Okay.
then from here, you can say, okay, well, this third 3 can come out in front. That is a step. That is a law step. Log base 3 of 3 minus log base 3 of x. This is law 3. I'm sorry, this was law 2. Probably need to write that in there.
All right.
Okay. And then this part here, log base 3 of 3. This is just 1. We talked about it a few times. This is really 3 times 1. This becomes 3 minus log base 3 of x. And that is your final answer.
All right.
Okay. These stop and thinks are a little bit more difficult because you do have to refer back to the logarithm. For some of them, like this number 3, it's only going to be will be 1 step. And that's always nice. Okay, expand log base 4 of x to the 5th and state the law that is indicated. Log base 4 x to the 5th. We've been doing this a bunch now. You can always bring that exponent out in front. This becomes 5 times log base 4 of x. And that's the same law 3 that we used in the last problem and a few other problems here. So you can actually see that here. We're just bringing that exponent out in front. And this is law 3. Nothing more to be done. Just writing that out.
Mm-hmm. Okay.
All right. So number 4 is probably the real one, the one you might see on a test or quiz, because it incorporates multiple laws. It's got a few kind of simplifications along the way and potential for some sign errors. So let's take a look here. We're going to just slightly rewrite this. 4 divided by 7x squared. Okay, that's our first step here. So notice that there's a quotient inside parentheses. All right. So what I want you to do here, I'm going to go grab that quotient rule. Let me go grab it here, right there. I want you to try writing this. And if you need help, M is on top and N is on the bottom. Could you try writing that out for me, please? And letting me know if you have any questions while you do that.
Sure, I can try. Um, so first it's gonna be um a log base 4.
Good.
Um, log base 4 with how do you say that exactly? Not like with
Of you say log base 4 of 4.
yeah, a 4
Okay.
minus log base 4 of 7x to the power of 2.
Good. Really good. Okay. So that's law 2.
Okay.
Okay. Now the next focus will be on this right here, 7x squared, probably. This is how most students do it. And you can see there's kind of a break there where there's a 7 and there's an x squared. And this is the product, the sum. Okay, so this is now this first log property, law 1, for just this one over here on the right, just this on the right though. So could you help me expand this one on the right using the product to sum property?
Okay. You want expanded, right?
Yeah. Yeah. So basically that's just to do this, say the kind of give me the right words or try to write it out on your own.
Um, I'm not. I think when to expand it, wouldn't it be easier if we put 7 with the base or something?
Right. So in this problem, M is 7 and N is x squared.
Mhm. So it would be like 7 plus log base of 7x squared. I don't know. I think I'm confusing
Base is
us.
still the base is still 4.
Hmm. This is confusing.
So I'm asking you just to look at this part here,
Okay.
just this part. And your M is 7, your base is 4, and your N is x squared. So just to rewrite this log part here, forget about everything else, just focus on this.
Well, maybe for expanding, we could do log base of log base of 4 of 7 plus x squared, maybe.
What about this other log here? You have to have 2
Oh,
logs.
so it'd be like log base 4 of 7 plus log base of 4 x squared.
Yes, exactly. Very good. This becomes log base 4 of 4. We're just bringing that down, minus log base 4 of 7 plus log base 4 of x squared. Now you might be wondering why I have parentheses. We'll get to that in a moment. But you
Right.
did that really well. That was good. It's really hard to do first time you see that.
Yeah, it took me just 2 attempts, but I did it.
All right. So the idea here is that parentheses are needed because you are subtracting all of this. You're not subtracting just the first one. I could give you a numerical example if you would like, but that's why this is one of those test questions, because students will tend to only subtract the first one, but not the second. And you have to subtract both. So this ends up being log base 4 of 4 minus log base 4 of 7 minus log base 4 of x squared.
So much log base. Oh my god.
Yes.
Okay.
Okay. All right. Now, a few more things we can do. There's really a 1 above the 4. Would you agree with that?
Yeah.
And these bases are the same. Okay. So this first one just becomes the 1. Okay. Now this 2 above the x squared, it also can come out in front. This
Mhm.
becomes minus 2 log base 4 of x, and that's law 3.
Okay. Okay.
So those 3 logarithm laws are going to be used throughout the rest of our lesson. So it's important that you have them down. I will point out, I think this is important because they don't show them this way. Let me snip them in one more time. So they show the logarithm rules from left to right, but they can also be used from right to left. So what I mean by that is if you see log base b of m plus log base b of n, you can write it as log base b of m times n. So if it depends on what you're given. If you're given a single logarithm with a product inside, you can expand it. If you're given 2 logarithms with the same base, it's called condensing or compressing, squeezing, making it smaller.
Uh-huh.
And then you can do the same thing for this second law. You can go backwards by taking the difference. This difference becomes a quotient. So in math, you always have kind of going forwards, going backwards. And this is the case here. If you have a third one here, if you have a number out in front, that number out in front becomes the exponent.
Hmm. Got it.
Sounds good. All right. Okay, so if you haven't figured out by now, the reason I throw in stuff like that is because you're going to use it on the next problem or two, and
Yeah.
that's what's happening here. I try to like lead you to, okay, this is what's coming up. All right, so here we go. We got a new problem here. It says to simplify and indicate which law is applied. Law, not law, log. So notice there's a difference here. And a difference becomes a quotient division. Can you tell me what goes in the numerator and what goes in the denominator?
I think what goes into the numerator would be 24 and the denominator would be 6.
Good. So this is law 2. They want you to indicate the law again.
Always with the law, man.
Right now, can you divide 24 by 6? Is that possible?
Yes.
Yes.
That would be, the answer would be 4. Wait,
Log base 4 of 4. Very good. There's no property for that. Um, now,
I,
when the bases are the same, the base is the same as you're thinking about taking the log of, what does this become? Or what
uh,
happens to this 1?
it would equal 1.
It just equals 1. And it's kind of law 3. I would actually argue it's a different one, but that's what it is. So we'll just go with it.
Mhm.
Is that okay?
Yeah.
Clear? As clear as it can be.
Hmm.
All right. Take a look at the next one here. This one I think it the product, the sum to product is a little bit easier. So I want you to look back at actually I take that back. So there, I guess I need to provide some more words. Okay, so I got to snip these in one more time. So when you are condensing, you tend to go in this order. When you're expanding, you tend to go in this order.
Hmm.
So because we're condensing, squeezing, we have to deal with this 3 in front of log base 3 of 2 first. Where does that 3 go according to this third law?
Um, the 3 would go to the third one.
You mean like above what letter? Or above what? Would it go above the
It would go where above M.
right? And M in your problem is 2. Very good. So I just need to kind of reframe this here. So this becomes log base 3 of 10 plus log base 3 of 2 cubed. And that's law 3. Is that okay?
Yeah.
All right. And so the next thing here is to simplify 2 to the power of 3. 2 to the power of 3 is 8. There's no law there. It's just a simplify step. By the way, do you like seeing on the right, like what is the explanation for it
Yeah,
each
I like
step?
it.
Yeah.
Yeah.
Okay. All right. So now you've got a sum. What happens when you have a sum here?
Um,
Look at your 3 logarithmic laws. Which one applies when you have a sum?
um, it's either law 1 or law 2, so
Say that again.
I don't know which law.
Okay, let's take a look at them together. All right. So the first one is a product to sum, basically multiplication to addition, or if you're going backwards, it's a sum to product.
Huh.
What
So,
do you see in your problem here?
well, we said it was law 3, so
What I'm trying to show you here, and I'm always trying to lead you the answers. This is a sum.
yeah, so we would use the first law for this one.
Exactly. Yes, exactly. So this becomes log base 3 of what times what? What goes in parentheses?
10 and 8.
Okay, and they multiply together to give you
80.
80. You got it. That's it. This is a lot like, excuse me, this is a lot like factoring, where you kind of don't know where to stop. So doing a lot of problems really helps. The way we're doing it, you're just going to get just enough exposure to it to say, oh yeah, I've seen that before, but really we'd like to do a bunch more problems to get this down. All right, having said all that, we are going to continue to move through this. We got number 7. Number 7 here. So I want you to first focus on the part on the left here. It's the part in the box there. And tell me how you can rewrite that. Look at those 3 laws and see which one applies.
The second one.
The
No,
second one applies to the whole thing.
yeah, sorry, it's the third one.
Yes. Can you tell me how you might rewrite that?
Okay, it would be a log base of 3. Uh,
Sorry, this is log, and when it's not written, I should have mentioned that it's base 10.
Yeah.
So let me actually put that in here. It's base 10.
okay. So 3 minus log 10 of 9.
Where does this 3 go in front?
Goes in, I was gonna say the exponent.
Yes, yes, very good. All right, really good. So the way, actually, I need to rewrite this. They've been wanting this up here, and then you say law 3.
Mm-hmm. Yeah, it's log 3.
All right, now, what is 3 to the power of 3?
3 to the power of 3 is 27.
So we have log base 10 of 27 minus log base 10 of 9. There's no law there. It's just a simplify step.
Mm-hmm.
Okay, now what law applies when you have a difference?
Law 2.
Law 2. So this becomes log base 10 of what divided by what?
It would be 27 divided by 9.
Good. And then if you can, you should always try to simplify whatever is there. What do you see in this case?
27 divided by 9 is 3.
Very good.
So the answer would be log 10 of 3.
Log base 10 of 3. Yes, that is correct. Good. That's tough. That's really tough to do kind of all that, especially seeing it for the first time.
Yeah.
It's like, what's going on here?
It's very overwhelming.
It sure is. Sure is. These self-paced courses are challenging because you really have to dig into the material that's new. Stuff that you've seen before, usually you can muddle through, but new stuff, almost impossible.
Yeah.
All right, we're on to number 8. Doing a great job today. So unfortunately, you cannot just go to the calculator for this one. They want you to use these values in the problem. Okay. And that's kind of like, why do I have to use these values? Well, because you have to. they don't there's no way to do it otherwise. So the first thing we actually are going to do is we're going to expand what's written here. Log base b of 15 minus log base b of 4 divided by 3. Now, thank goodness we don't have to say the law anymore. We just have to do the steps, which I like. So now on the left here, can you think of another way to write 15 as a product, like two numbers that multiply together?
Maybe. Okay,
So,
so
so can you make 15 out of a 3, 4, or a 5?
we can make 15 out of 3 and 5 when you multiply it.
3 times 5, right? So this becomes log base b of 3 times 5.
Mm-hmm.
Okay. And the reason we would do that is because we can now expand it using the product and sum.
Right?
All right, so the first one becomes the sum of two logarithms. Would you try to write the first one for us, please? Basically
Sure.
everything on the right, on the left here.
Okay. Log base b 3 times 5. I was
Plus log base b of
okay,
5.
plus log base b of 5.
Yeah. Now the one on the right, is a quotient. It becomes a difference.
Uh-huh.
So it becomes log base b of 4 minus log base b of 3, but you're subtracting all that in parentheses. I know there's no parentheses in the previous line, but you end up subtracting whatever's in here.
Mm-hmm.
So this becomes log base b of 3 plus log base b of 5 minus log base b of 4 plus log base b of 3. All right, now we're going to use the given values. So log base 3 is of b is 0.5646, 0.5646 plus 0.8271 minus 0.7124 plus 0.5646. So the only thing to do from here is to go to the calculator and determine that value. Because we're basically running out of time, I'm going to do that as well and give you the result here so we can finish out this problem and not be stuck in the middle of
Yeah.
1.5646 plus 0.8271 minus 0.7124. So no, then this answer is meaningless. I mean, it just is a number. So don't
Mhm.
take too much away from that value. All right, we're going to go ahead and stop right here for today.